Right, the next question is June 07, paper 2, question 4. Now there were, I think out of the 4 questions we have here, 3 of them came from paper 2 and they were question 4, but unfortunately the last one came from paper 1 and it was question 4, so you can't rely on this type of question always being on paper 2. This shows you again another electromagnetic circuit. This time it's a relay switch. So you've got 5 marks for explaining. So the question says, describe what happens in circuit A in the relay and in circuit B when the switch S is closed. And you've got 5 marks for doing that. So the first thing, when the switch is closed, you have current flowing in A. And what does that do? It turns the electromagnet on. So the electromagnet, I'm just going to write EMAG again, is on or magnetized. So that's 2 marks you've got already. That attracts the iron armature down towards it and closes. So if we write that first, iron armature attracted to the electromagnet. And then as it swings down this direction, this part here swings up and that closes the contact, so contact's closed. That's a 4th mark. A 5th mark for saying then circuit B switched on. And if you wanted to, if you had read the fact that there's a water pump here, then you could write water pump on. Now again, there's 6 marks here, 1, 2, 3, 4, 5, 6, and they will give you any 5 out of 6. Next question says, what type of material should part D be made of? So let's have a look at part D. There's part D there. And part D is connecting the circuit. You can see that these 2 wires here are very, very thick. And this is what a relay switch is used for. It's used, a small current is used to switch on a very large current, which would really be probably in something like a starting motor. This part D here is separating these 2 wires, and it should really be made of some kind of insulating material. Now if that wasn't an insulating material, this circuit would be on permanently, and that's what you don't want. So the reason why it has to be an insulator, if it was a metal or a conductor, if a conductor, B would be on permanently. And obviously you don't want that. Right, the next part of the question says, and I'll just hold this down here so you can see it. It says, why is the core of the relay made from iron? So there's the core of the relay there, made of iron rather than copper. And of course that's because it is a really good magnetic material and it intensifies the magnetic field. So iron is a magnetic material, MEG material, and it intensifies or intensifies the magnetic field. You could also say there that copper is not then. Okay. Next question. The diagram below shows a coil of insulated copper wire carrying electric current. The directions show the direction of the current. Mark the south pole with an S. So we're going to look at the direction of the current. Right hand grip rule again. You can see that the arrows are coming down, so you have to put your hand like that. This is the north and that's the south. And then 3 marks is time for drawing on carefully the direction and shape of the magnetic field lines. This time in this question they've allowed you 2 marks for the shape. So 1 for a line through the middle, and they say these lines here have to be parallel, and 1 for the 2 loops. And then the last thing is to put on the direction. So there's 2 marks for the shape and the direction then north into south. Okay. So part C is a strong permanent magnet is placed inside a coil of insulated copper wire. So this is obviously an electromagnetic induction question again, but in this case it's already set up, the magnet's already there. The ends of the coil are now attached to a sensitive ammeter. Will an electric current be detected on that ammeter? Give a reason for your answer. So you've already got the magnet sitting in there. It's not telling you that it's moving. It's not telling you that there's any change in it, that it's been switched on or off. And so, therefore, there's going to be no current detected. And the reason is there's no change in the magnetic field. I'm just going to write mag field. Or you could say there's no movement. No movement. So to make it work, it says using no extra equipment. So that means you can't add anything to this setup here. It says describe how you can make a current flow in the ammeter, and the answer is just to move the magnet. And you would probably finish that off with in and out. And that would get you 2 marks. So there's 2 marks up here, one for saying no and one for the reason. And just move the magnet would get you 2 marks there. With the same equipment, what could be done to make the current larger? So to make the current larger, what you could do is to move, you can't, it says with the same equipment, so you can't have no option of adding more coils or anything like that. So you have to do something else. And what could you do to make the current larger? You could move the magnet faster. So this is just like the dynamo on a bike. When you pedal faster, the little magnet turns faster, and that induces a greater current in the coil of wire. So just like the dynamo on a bike. Explain why the current would be larger. And the reason is because the field lines, the magnetic field lines, are cut faster. Or you could say that there's a greater change in the magnetic field. And the last part of this question, name the process used to produce electric currents in this way. And again, you just have to learn the name of this, and it's electromagnetic induction. And it's only worth 1 mark, but 1 mark is the difference between 2 grades, and you really must learn that, electromagnetic induction.